Once again, we have a tangent line. Notice this line that's cutting across that doesn't enter the circle, but it touches it, makes contact at one point, and it creates a right triangle. And we want to solve for the missing sides of it. But you may notice in here we have two different sides we're going to have to find in order to solve it. We must find y first, and once we find y, then we can add it to this section that it gives us a value for, of 4, and then we can find x. And you may not recognize how to find y. And if you don't, if this looks confusing because you go, you know, Mr. H, I don't know how I'm going to find y and x. Well, then watch this video very closely because I'm going to explain to you how we would know what y is. So for that, we're going to have to go back to an idea that you learned much earlier in school, and it had to deal with radius and the diameter of a circle. So for instance, this line that goes from one side all the way to the other, we also call that a chord because it goes from one part of the circle to the other. And notice it's dead center inside of there. We call that the diameter. So I'm going to go ahead and write that out real quick. This right here is the diameter. And it cuts across the entire circle. In other words, it cuts the circle in two halves. Now, notice we have a single line from the center of the circle that goes to an edge. So if we have a single line that goes from the center of the circle to the edge, instead of calling it diameter, we actually call it a radius. And there is a relationship between the radius and the diameter. So I'm going to go ahead and prove that to you real quick. So I'm going to take my tool here and we're just going to measure some things. So if you notice, I have this, and if I go from the center there over to this edge, it's 4 centimeters. Now if I were to measure the entire thing, I'm going to hold this up so you can see it. It actually measures out as 8 centimeters. So while the diameter is 8 centimeters, half of the diameter, which is also known as the radius, is only 4 centimeters. So that relationship exists. And so I'm going to write just a note right here. The diameter is equal to 2 times the radius. And the radius is equal to 1/2 the diameter. Now that's just refreshing your memory on some things, but notice that anytime I go from the center of a circle to an edge, it's the radius. And it doesn't matter where it is. It doesn't matter where I make that line. Anywhere in here, if I go from the center to the edge, it's the radius. And it'll always be the same value. Now, with that in mind, I'm going to move this up. And what I hope you realize is, looking back at this, is that this simply is a radius. And so I'm going to write that in there. So let me just write it on there. You could look at this as the radius, right? It goes from the center to the edge of the circle, or to the circumference. And you could also look at this one right here as a radius, because it goes from the center of the circle to the circumference. The reason I'm mentioning that is if this radius is 6, then y must also be 6. So even though they put a variable here, or they didn't give you that measurement, you can find it just by looking at this and reasoning that both of these are radius, and so therefore they are going to be the same length. So I'm going to go ahead and write right here. We already have one of our answers. It didn't require any math. We just had to look at it and recognize the relationship and realize that both of these are radius. So y is equal to 6. So now all we have to do is find x. Now that we know that y is 6, if we want to find x, we need at least 2 sides of the triangle to use the Pythagorean theorem. Now we have one side, right? This over here is a leg, and I can see that this right is a tangent line, and so that means that we have a right angle right here. And across from it, if we were to take this whole line, it is the hypotenuse. So I'm going to put right here, this is leg A of the triangle. This bottom side, x that we're looking for, is actually leg B of the triangle, because it touches the right angle side. And across from here is the hypotenuse. And to get the value of the hypotenuse, we just have to add this section, which is a radius, to this other section outside of the circle, which happens to tell us that it's 4. So I'm going to take 6, and I'm going to add it to 4. So if I write that over here, 6 plus 4, and that's going to give me 10. So I know that C side C of the triangle is equal to 10. And I have everything I need now to use the Pythagorean theorem. I know what the hypotenuse is, which is 10, and I know that this leg is 6. And this is the one I want to find, which is x. So let me go ahead and set it up. I have a squared plus b squared is equal to c squared. We know that a is 6. I'm going to circle it and write it down. So a is going to be 6 squared plus, and we know that b is going to be represented by the variable x. So for b, I'm just going to put x squared, and that's equal to c, the hypotenuse, squared. And the hypotenuse, when we added these two numbers together, is 10. So I'm going to write 10 squared. So the next thing we want to do is we want to isolate x, and to get x by itself and isolate it, we need to take this 6 squared and subtract that whole term and move it to the right side of the equation using inverse operations. So I'm going to subtract 6 squared. That cancels out the 6 squared on the left side of the equation. I'm then going to subtract 6 squared from the right. And if I put that in my calculator, notice I have 10 squared minus 6 squared. And that's going to leave me with 64. So this becomes 64. Bring down my equal sign, and all I got left on the left side of the equation is x squared. Now we don't want x squared, right? We just want x. So I need to take the square root of both sides. That cancels out the square on the x, and I'm simply left with x is equal to, and then in my calculator I'm going to hit the second button and then the x squared button so I can get my radical symbol, and I'm going to type in 64. And notice it gives me 8. So the answer to this question is x is equal to 8. So while this question was 2 parts, we had to know that this was a radius and that y was 6. Then we used that value, added to this other value, right, which gave us the whole length of the hypotenuse.